Large language models, or LLMs, have become incredibly powerful tools for tasks like answering questions, generating text, and even creative writing. However, these models often pick up biases from the vast amounts of data they're trained on, which can lead to unfair or harmful outputs, especially towards underrepresented groups. For example, an LLM might unfairly associate certain professions with specific genders based on skewed patterns in its training data. In this paper titled, FairSteer, Inference-time Debiasing for LLMs with Dynamic Activation Steering, researchers from Zhejiang University and Zhejiang Lab propose a new way to tackle this problem. The key idea is to debiase the model right at the inference stage, meaning when the model is actually generating responses, without needing to retrain or fine-tune the entire model. This approach is more efficient and practical compared to traditional methods. First, let's look at why existing debiasing techniques fall short. There are mainly two types: prompt-based methods and fine-tuning-based methods. Prompt-based approaches involve crafting specific instructions or prompts to guide the model towards unbiased answers. For instance, you might add a sentence like, "Please respond without any gender bias," to the input. While this can work, it's unstable because small changes in the prompt wording can drastically alter the results, making it unreliable in real-world scenarios. On the other hand, fine-tuning-based methods require retraining the model on carefully curated datasets that balance out biases. Techniques like projection-based debiasing or contrastive learning are used here. These methods offer more control, but they come with heavy downsides. They demand a lot of computational power, risk causing the model to forget other useful knowledge, a problem known as catastrophic forgetting, and rely on hard-to-obtain annotated datasets. This is where inference-time debiasing steps in as a simpler alternative. The researchers draw inspiration from the linear representation hypothesis, which suggests that certain features in LLMs, like sentiment or truthfulness, are encoded as distinct, linearly separable directions in the model's hidden activation spaces. They extend this idea to fairness-related features, hypothesizing that biases can be isolated and adjusted in these spaces without altering the core model. Enter FairSteer, a framework that operates in three main steps. The first step is biased activation detection. Here, the team trains a lightweight linear classifier on the model's activations. Activations are the intermediate outputs from the model's layers as it processes input. By using a small set of labeled data, where activations are marked as biased or unbiased, the classifier learns to identify when and where bias signatures appear in the activation space. This doesn't require retraining the entire LLM. It's a quick, efficient process. The second step involves computing debiasing steering vectors, or DSVs. These vectors are derived from pairs of contrastive prompts, one that's biased and one that's unbiased. For example, imagine a prompt about a board meeting where a man and a woman are late, and the model might incorrectly assume the woman is the secretary. By feeding both a biased version and an unbiased version of this prompt into the model, the researchers capture the activations for each. They then take the difference between these activations and average it across multiple pairs to create the DSV. This vector essentially represents the direction in the activation space that encodes the bias. Finally, in the third step, dynamic activation steering is applied during inference. Once the DSV is ready, it's used to adjust the model's activations in real time. Specifically, for a given input, the system first detects biased activations using the trained classifier. Then, it adds or subtracts the appropriate DSV to steer the activations towards a more neutral direction. This adjustment happens layer by layer in the model's architecture, ensuring that the output becomes less biased while preserving the model's overall performance on other tasks. To illustrate, think of the model's activation space as a high-dimensional map. Biases are like unwanted paths on this map, and the DSV acts as a corrective force that nudges the model's path back to a fairer route. The process is dynamic because it adapts to the specific input and layer, making it more precise than blanket debiasing techniques. The paper evaluates FairSteer across 6 different LLMs, testing it on various tasks. These include question-answering scenarios, where the model might otherwise give biased responses, counterfactual input evaluation, which checks how the model handles hypothetical situations with potential biases, and open-ended text generation, to ensure the method doesn't stifle creativity. The results show that FairSteer outperforms existing methods in reducing bias while maintaining or even improving the model's accuracy and fluency. For instance, in question answering tests, FairSteer reduced biased responses by a significant margin without degrading the model's ability to answer unrelated questions correctly. One of the strengths highlighted is its efficiency. Since it only requires training a small classifier and computing DSVs from a few prompt pairs, it's computationally lightweight and can be applied to pre-existing models without any modifications. The researchers also note that this method avoids the pitfalls of reducing output diversity, which is a common issue with other inference-time strategies that simply suppress potentially biased tokens. Overall, FairSteer represents a promising step forward in making LLMs more ethical and reliable. By leveraging the linear structure of activation spaces, it offers a flexible, inference-time solution that could be extended to other types of model behaviors beyond just fairness. The code for this framework will be released, allowing others to build upon and test it further.